All right, what we want to do is perform the indicated operation, and we want to simplify the radicals. So here what I have is -4 root 54, so I come over. Now this is the cube root, so I'm going to look at my cubes. 54 is 27 times 2, so I really have -4 times the cube root of 27 times 2, which is -4. Cube root of 27, the cube root is 3. So we get times 3 times the cube root of 2, so that's -12 cube root of 2. There's a couple ways we can do this. You could take the square root of the top divided by the square root of the bottom, or if you're lucky, you can recognize 64 is divisible by 16. So this equals the square root. 64 divided by 16 is 4. Square root of 4 is 2. All right, strategy for this. You got to remember the strategy here is to rewrite. Put the coefficients in front. I have a 3 and I have a -5. Now put the roots. I have 12 and I have root 3. 3 times -5 is -15. Root 12 times 3 is root 36. The square root of 36 is 6, and -15 times 6 is going to be -90. For D, it looks simplified, but we have that square root on the bottom, so you need to rationalize. We're going to multiply the top and the bottom by root 2. Root 3 times root 2 is root 6. Root 2 times root 2 is 2. And then we leave that. Notice I can't simplify. Root 6 divided by 2 is not root 3 because the 2 doesn't have a square root. This root 6 is some random number, right? If I had root 6 over root 2, I would be good to go. So again, 6 over root 3 is not root 2. Over here, we need to rationalize root 3 over root 3. So then I'm left with 6 root 3 over 3, and we can simplify these two because neither of them have a radical. 6 divided by 3 is 2, so I get 2 root 3 for this. F is being squared. We have to square all the numbers inside. We have two numbers. We have 3 and we have root 5. So this is 3 squared and this is root 5 squared. 3 squared is 9, and we know when we square a root, we just get the number underneath the radical sign. 9 times 5 is 45. Both of these numbers here are cube roots, so we can combine that. This is the cube root of 48. Okay, 48, what is that? Is that 6 times 8? Okay, perfect. So this becomes the cube root of 8 times 6, which is the cube root of 8 times the cube root of 6. The cube root of 8 is 2, so this is 2 cube root 6. Make sure you put that cube root symbol. You need to have that 3 there. All right, last problem, number 7. Amy, Sarah, and Jeff each attempted to solve the following problem, but they got different answers. Okay. The width of a rectangle is 2 root 5. The length of the rectangle is 4 more than the width. So the length equals 4 plus W, which is 2 root 5 plus 4. Yes, that is true. Find an expression for the area. All right, so what we're doing is we're taking the width and we're multiplying by the length. Got it. So width, 2 root 5 times 2 root 5 plus 4. Here's the problem. Here, I'm only multiplying these two pieces together, and 2 root 5 is not the length, so that's not going to work. Okay, so here only 2 root 5 is multiplied. Okay, let's take a look at Sarah. So Sarah looks good. This starts. So this is my length, or this is my width, and this is my length. Here, same thing. This is my width, this is my length. So these two start off both right. Let's keep going. For this one, we need to distribute. So here, 2 times 2 is 4. Root 5 times root 5 is root 25. 2 times 4 is 8, and root 5 has nothing to multiply by. This looks good so far. 4 times root 25 is really 4 times 5 is 20. This is the right one. Sarah is right. So we have to talk about why this one's wrong. So let's come over. So 2 root 5 times 2 root 5 is 4 root 25. 2 root 5 times 4, I can only multiply the 4 and the 2. So I get 8 root 5. Yes. This is 20. Excellent. 8 root 5 stays. These are not like terms. Look at 20 does not have a root 5. This is equivalent to saying 20 plus 8x. You can't do anything, right? So we can't add the 20 plus the 8. So these are not like terms.